In this video, we are going to study the preparation of insoluble salts, starting from preparation of insoluble salts from soluble salts, right? Soluble salts. So, just we are going to make the roadmap that AgNO3 to AgCl. Another PbNO3 whole twice to PbCl2. Another PbNO3 whole twice to PbSO4. Another PbNO3 whole twice to PbCO3. Another CuCl2 or CuSO4 or CuNO3 whole twice to CuCO3. Another ZnCl2, ZnSO4 or ZnNO3 whole twice to ZnCO3. Another similarly FeCl2 or FeSO4 or FeNO3 whole twice to FeCO3. These we are going to prepare, or you may also take BaCl2 or BaSO4 or BaNO3 whole twice to not BaSO4, BaCl2 or BaNO3 whole twice to BaSO4, right? Another similar compounds and the product is BaCO3. These we are going to prepare. These compounds which we have taken on the left side, they are soluble in water. Circle the salts which are inside the circle, they are soluble in water, right? And the right side are insoluble in water. So we need to prepare these salts starting from AgCl. See, first is AgNO3 is aqueous, which is soluble in water. Second, PbNO3 whole twice aqueous, which is soluble in water. Another, so you take what? Dilute HCl here to give what? To give Cardi white PPT. Cardi white PPT of AgCl plus HNO3. You can also prepare this AgCl by the reaction of AgNO3 aqueous, that is in water, plus NaCl aqueous, because chloride is the ion which will take the position of NO3 negative to form Cardi white PPT of AgCl, and plus NaNO3 will be left as aqueous. So in this way we become able to prepare AgCl. Second, we are going to prepare BaSO4. For BaSO4, you may take BaCl2, you may take BaNO3 whole twice. BaNO3 whole twice. If you are taking Ba, this is aqueous, water soluble, and these two are water soluble. So we are taking dilute HCl. So it is aqueous. So dilute H2SO4, right? Aqueous. So it is forming white PPT of BaSO4, right? Plus twice HCl or BaNO3 whole twice will react with dilute H2SO4 as well to form similar compound BaSO4 as a white PPT plus 2HNO3. In place of H2SO4, right? In place of H2SO4, you can also take Na2SO4 solution because it is also water soluble and it has sulfate ion in it. So, or BaCl2 can also be treated Na2SO4, BaNO3 whole twice can also be treated with Na2SO4, aqueous, aqueous, aqueous and aqueous to form BaSO4 as a white PPT plus 2 NaCl and here BaSO4 as a white PPT plus 2 NaNO3, right? Now we are going to prepare lead salts starting from PbNO3 whole twice. This is the third part plus dilute HCl or PbNO3 whole twice plus NaCl aqueous. So you will take 2HCl and 2NaCl. Mutual exchange of ions will take place to form PbCl2 as a white PPT plus 2HNO3. And here same compound will be formed PbCl2, but the byproduct will be 2NaNO3. And we know that PbCl2 is white PPT. So this is a kind of precipitation reaction where one of the product is insoluble in water, while reactants are soluble in water, isn't it? Number 4, if you want to prepare sulfate, so you will have to take PbNO3 because this is only the nitrate of lead which is water soluble. So here you have to take either dilute H2SO4 or you have to take Na2SO4 solution in the aqueous state to form one of the insoluble solid, that is PbSO4 as a white PPT plus 2HNO3. Here PbSO4 as a white PPT plus 2 NaNO3 because here we have Na2SO4, so you will get NaNO3. So these are the white PPT, isn't it? Next we are going to prepare PbCO3. So to prepare PbCO3 you will have to take lead nitrate, PbNO3 whole twice. You will have to take lead nitrate. Then the question is we want to prepare what? PbCO3. It means we have to bring CO3 in place of NO3 whole twice. So which reagent should be taken? The reagent will be only one, Na2CO3. The aqueous and aqueous. Then you will get the product 2NaNO3. Now question arises in our mind that why not H2CO3? The H2CO3 will not be taken as a reagent because it is unstable compound. It is unstable compound while Na2CO3 is a stable compound. So you can't take H2CO3. H2CO3 exists only in, this is a carbonic acid which is a weak acid and very weak. So it exists only under high pressure. So normally it is unstable compound. It will get decomposed into CO2 and water. That's why we cannot take this one. Then we want to prepare ZnCO3 from ZnCl2, ZnSO4 or ZnNO3 whole twice. Among these three, any one can be taken because they all are in which state? Aqueous state. So you want to prepare CO3, you need to take Na2CO3 only, Na2CO3 only, and Na2CO3 only. So what will be the product? The product will be white precipitate. ZnCO3 is a white solid. The white PPT of ZnCO3, white PPT of ZnCO3, and white PPT of ZnCO3. And what will be the remaining byproduct? First we will have 2 NaCl in the second we will have what? C, Na2SO4, and in the third one we will have 2 NaNO3, and they will be in aqueous state. So one of the white solid is forming, which is a white precipitate. I think it should be clear to everyone. Now moving forward, we are going to prepare CuCO3 from, reactant should also be solved. So CuCO3 from CuCl2, CuCO3 from CuSO4, CuCO3 from CuNO3 whole twice. Because these reactants are water soluble, and for the reaction to take place, one of the compound or both the compound should be water soluble. So here we will take again what? Na2CO3, Na2CO3 and Na2CO3. H2CO3 will not be taken because H2CO3 is unstable, and this compound Na2CO3, which is a sodium carbonate, is stable to heat and also soluble in water. So mutual exchange of ions will take place. You will get CuCO3 plus first 2 NaCl, and then the second CuCO3 plus Na2SO4, and in the third CuCO3 plus 2 NaNO3 will be the byproduct, and these will remain as aqueous, while CuCO3 will be prepared as a green precipitate. Right? Now seventh one, we want to prepare FeCO3. So you can take FeCl2, you can take FeSO4, you can take FeNO3 whole twice, because these are also water soluble. Plus again you will take what? Na2CO3, Na2CO3 and Na2CO3, and this will be aqueous, aqueous and aqueous. Again I am saying again and again, H2CO3 will not be taken. So you will get FeCO3, you will get FeCO3, you will get FeCO3. The first product will be FeCO3, FeCO3. Freshly prepared is a white solid, but kept for some time it turns to pale yellow solid. Okay, so remaining product will be 2Cl and 2Na. So you will get 2 NaCl. Second, 2 Na and SO4, you will get Na2SO4, and third is you will get 2 Na and NO3, so you will get 2 NaNO3. They will remain in the form of aqueous solution. In this way we are able to prepare insoluble salts from soluble salts. Now we are going to prepare the next one, that your insoluble to insoluble. We are going to prepare insoluble to insoluble, right? Insoluble to insoluble. So first of all, we need to know which are insoluble in water. So I'm telling you, starting from ZNO insoluble, this is a metal oxide. CuO is a insoluble. PbO is insoluble in water. You need to take FeO, insoluble in water. Another, we are taking ZnCO3, insoluble in water. CuCO3, insoluble in water. PbCO3 is insoluble in water. FeCO3 is insoluble. These all are insoluble in water. So first of all, we need to convert them soluble state. How can you convert? The first, we need to prepare ZnO to ZnCO3. So ZnO insoluble, ZnCO3 is insoluble. These all are two-step reactions starting from, because we need to dissolve it. We need to dissolve ZnO. So to dissolve ZnO, it will be treated either with HCl, it will be treated with H2SO4, it will be treated with dilute HNO3. So any one of acid can be taken to form salt and water. So what will be the product? First one, ZnCl2 plus water. ZnCl2 is soluble in water. ZnSO4 plus H2O. So ZnSO4 is also soluble in water. ZnNO3 whole twice is also soluble in water. You have made ZnO soluble by converting it into either chloride or nitrate or sulfate. Now you can prepare ZnCO3. See, if you're taking first one, ZnO plus HCl, the first reaction will be ZnO plus dilute HCl. So first you prepared ZnCl2 plus H2O and 2HCl. This ZnCl2 is soluble in water. Now it can be made insoluble like a previous equation, ZnCl2 plus Na2CO3 aqueous and aqueous to form what? ZnCO3 plus 2NaCl. So this is a 2 marks question to be asked. If you need to prepare ZnCO3 using dilute H2SO4, so first you will convert, second part, ZnO plus dilute H2SO4 to form ZnSO4 plus H2O. Now it becomes soluble, and then ZnSO4 will be treated with Na2CO3 aqueous and aqueous to give rise to white PPT of ZnCO3 plus Na2SO4. So this is a 2 mark question. Same question I am repeating, isn't it? Now third one, if you need to convert ZnO to ZnCO3 by using HNO3, the first ZnO will be treated with dilute HNO3 using 2 HNO3, because valency of Zn is plus 2. So you need 2 NO3 negative. So here you will have ZnNO3 whole twice aqueous plus H2O, and this ZnNO3 whole twice will be treated with now Na2CO3 solution aqueous to form white PPT of ZnCO3, white PPT of ZnCO3 plus 2NaNO3. Similar reaction will occur with CuO. CuO to CuCO3. It can be prepared in by three methods. First one, CuO plus diluted HCl. Because CuO is insoluble in water, it is made soluble either by treating with diluted HCl to form CuCl2 plus H2O. This CuO is a black solid, and the CuCl2 will be now blue solution. This solution is now treated with, which is a blue solution, is now treated with Na2CO3 aqueous to form CuCO3 as a green solid plus 2NaCl. Now this is a 2-mark question, isn't it? Next, if you want to prepare CuCO3 using H2SO4, so CuO is a black solid, dilute H2SO4 to form CuSO4 plus H2O. This is the first step. CuO is a black solid and CuSO4 is again blue solution. This CuSO4 is now as a blue solution will be treated with Na2CO3, not H2CO3, to give rise to CuCO3 as a green PPT plus Na2SO4. Now third one, if you want to prepare CuCO3 by using HNO3, the first CuO plus dilute HNO3 to give rise to CuNO3 whole twice plus H2O. CuO is a black solid, right? This is a black solid. This CuNO3 will be bluish green solution. Now this bluish green solution will be treated with Na2CO3 aqueous to give rise to CuCO3 as a green solid, right, plus 2NaNO3, which will remain in the aqueous state. I think it is clear that how to prepare. Another, we are taking Cu, that FeO to FeCO3. So same will happen. FeO plus dilute HCl or FeO plus dilute H2SO4 or FeO plus dilute HNO3 to make, actually this FeO is insoluble. So to make it soluble, it can be treated with either dilute HCl or dilute H2SO4 or dilute HNO3. So you will get FeCl2 plus H2O, FeSO4 plus H2O, and your FeNO3 whole twice plus H2O. This FeO is also black in color. It is also a black solid forming green solution. Sometimes we say light green solution, right? The second step will be this FeCl2 plus Na2CO3 to give rise to pale yellow solid FeCO3 plus 2NaCl. So this is of 2 marks now. Second, Fe, you have prepared FeSO4. So FeSO4 aqueous, Na2CO3 aqueous, aqueous is master. So FeCO3 plus and your Na2SO4. So this is again of 2 marks. Similarly, FeNO3 whole twice plus that Na2CO3 aqueous to give rise to FeCO3, which is a pale yellow solid, to form 2NaNO3. Freshly prepared is a white solid, but after some time it turns yellow. Now next is, if you want to prepare PbO to PbCO3, yeah, PbO to PbSO4, right? So both are insoluble. This PbO insoluble, it is a yellow solid, and PbCO3 and PbSO4, they are white solids. So if we need to prepare this one, the PbO first treated with dilute HNO3 only, not with any other compound, because nitrates of lead are soluble in water. So now it becomes colorless solution. Pale yellow to yellowish solid to colorless solution. Now this PbNO3 whole twice is either treated with dilute HCl, so 2HCl, or treated with NaC, 2NaCl aqueous to form PbCl2 as a white solid plus 2HNO3, or PbCl2 plus as a white solid plus 2NaNO3 aqueous, isn't it? So this is a white PPT. Another, we are taking PbO to PbSO4. Same will happen. PbO to PbSO4. Both are insoluble. So we want to make this PbO soluble in water. So it will be treated with dilute HNO3 or and form what? PbNO3 whole twice plus H2O. So now it becomes colorless solution, yellow solid to colorless solution. Now this PbNO3 whole twice on reaction with dilute HCl or on reaction with the dilute H2SO4, not HCl, here either or Na2SO4, so they will be in aqueous state to prepare PbSO4 as a white solid plus 2HNO3 or PbSO4 as a white solid plus 2NaNO3. The NaNO3 and HNO3 will be liquid aqueous solution and PbSO4 will turn to white solid. Is that clear to everybody? Okay, next question will be asked. To prepare PbCl2 from PbCO3. PbCl2 from PbCO3. PbCl2 from PbCO3. So this is PbCO3, This is PbCl2. Now you have understood what to do. We need to dissolve this PbO in water, and to dissolve it PbO in water, we need to convert into PbNO3 whole twice, PbNO3 whole twice, and H2O plus CO2 will be formed. See, remaining compound is H2CO3, and as I earlier I told you again and again that that H2CO3 is unstable compound, so it cannot be taken as a reactant even if it is formed. Wherever it is formed, it will get decomposed into water and CO2. So now this become aqueous solution. This was white solid. PbCO3 was white solid. So this PbNO3 whole twice aqueous will be now treated with either dilute HCl or PbNO3 whole twice, which is aqueous, is treated with NaCl aqueous to give rise to PbCl2 as a white PPT plus 2HNO3, or PbCl2 as a white PPT plus 2NaNO3 aqueous, isn't it? So this is a white PPT formed. So now you are getting, slowly you are getting that what to do. We all are writing, we are writing all the reaction in two-step reactions. First, insoluble to solid, soluble, then soluble to insoluble. Now we need to prepare PbSO4, the PbCO3 to PbSO4. Both are insoluble, white solid and white solid. So you need to make it soluble in water. So if you need to make it soluble in water, you have to react it with HNO3 to form PbNO3 whole twice. Now it is aqueous and colorless solution. What is left? After multiplying 2 in HNO3, the left part we are seeing that it is H2CO3 and it is unstable. It get decomposed into H2O and CO2. Now this PbNO3 whole twice will be treated with either dilute H2SO4 or this PbNO3 whole twice will be treated with Na2SO4 aqueous to form, first one, NO3 will be exchanged by SO4 to form PbSO4 plus 2HNO3 is a white solid, right? Second, here this one PbSO4 plus 2NaNO3 aqueous, and this will be what? White solid. And this was aqueous as a colorless solution. Now these all are two-step reaction. Either this one may be taken or this one may be taken. So this is a 2-mark question, and it is generally asked that how to, and it is very important, isn't it? Now we are going to prepare some laboratory preparations of salts. We will prepare blue vitriol. You know blue vitriol, CuSO4 dot 5H2O. Another, so first we will take this one. How to prepare it? See, first of all, Cu or CuO or CuOH whole twice as a reactant are taken. In case of CuO and CuOH whole twice, we will take dilute H2SO4, and there will be the formation of CuSO4 plus H2O. CuSO4 plus twice H2O. This is a neutralization reaction. Okay? Because these two CuO and CuOH whole twice, they are the basic compound, and base and acid react together to form salt and water. So this is a neutralization reaction where we have prepared CuSO4. But there is an important note to remember that copper is less reactive to hydrogen. So does copper displace hydrogen? No. Why? Because copper is below hydrogen in the reactivity series and less reactive. So it will not react with dilute H2SO4. It will not react with dilute H2SO4. No. This reaction will not occur as a Cu is less reactive than hydrogen. So it cannot displace hydrogen. So how to convert it into sulfate? So we have studied that if we take concentrated H2SO4, this will react. Reason, concentrated H2SO4 will act as oxidizing agent here. Here it will act as oxidizing agent to oxidize Cu into Cu2 positive, CuSO4. That is Cu2 positive, and will undergo self-reduction to form SO2, and water is formed. The SO2 is the reduced form of H2SO4 here. So H2SO4 undergoing reduction to form SO2 and also causing oxidation of Cu into Cu2 positive, because here is Cu2 positive. The Cu2 positive get oxidized by H2, concentrated H2SO4. So you need to take 2 H2SO4 and twice H2O. Why 2 H2SO4? Because Cu2 positive will be formed as a CuSO4 blue solution. Now you want to make it a crystal. So this reaction is very important for your Cu and concentrated H2SO4. Reason, dilute will not react. Dilute may copper is less reactive than hydrogen, but in concentrated it will react because of its oxidizing property, isn't it? Then next step is to form blue vitriol crystal. So what we will take? We will take saturated solution where no more solute can be dissolved at fixed temperature is saturated solution. So it will be evaporated. Evaporated means that water will vaporize slowly without heating. The solution will be left for some time to get the crystal, blue colored crystals of CuSO4.5H2O. So these blue crystals will be formed, and this is called blue vitriol. Now where from water molecule are coming? That excess of water was present in a saturated solution, out of which 5 water molecule will be added to CuSO4 in the form of water of crystallization, isn't it? So this was the blue vitriol. Next will be green vitriol, white vitriol. To prepare white vitriol, we need to take Fe, Zn, ZnO or ZnOH whole twice. This zinc is more reactive than hydrogen, and these ZnO and ZnOH whole twice are amphoteric oxides. What kind? Amphoteric oxides and hydroxides. Why? Because they react with both acids and strong alkali. With both they will react. So zinc is more reactive than hydrogen. So we will take dilute H2SO4 here. And the lower two reactions will be neutralization. So here definitely dilute H2SO4 will be taken to form ZnSO4 plus H2 will be given out. ZnSO4 plus water will be formed. ZnSO4 plus two water molecules will be formed. See, two water molecules, one water molecule and hydrogen. And this ZnSO4 likewise CuSO4 will add 7 water molecules, and this is the saturated solution of it, to form ZnSO4.7H2O. White colored crystals will be formed, and this is called white vitriol. Then the question arises here that why do we not take concentrated here? So if we that are able to prepare ZnSO4 from dilute H2SO4, then no need to take concentrated H2SO4. And if concentrated H2SO4 is taken, then reaction will be changed. And as I told you, in case of Cu, concentrated H2SO4 was used and it was oxidizing agent. Here concentrated H2SO4 will act as oxidizing agent to form likewise CuSO4, ZnSO4, and H2SO4 gets reduced to form H2O and SO2. So SO2 is the reduced form of H2SO4. So here 2 H2SO4 and 2 H2O, that can be used. But if we are able to prepare ZnSO4 by using dilute H2SO4 from Zn, so no need to take your that concentrated. If you are taking, then it will act as oxidizing agent, then it will form ZnSO4, water and SO2. Now third is green vitriol. Green vitriol is FeSO4.7H2. So here you need to take either Fe or FeO or FeOH whole twice. Fe is more reactive than hydrogen, and these two are basic in nature. So Fe is more reactive than hydrogen, so we need just dilute H2SO4. We don't need concentrated here. If we don't need, we will not use. If we will use, only the reaction type of reaction will be changed to form what? FeSO4 plus H2. Second, FeSO4 plus H2O. Third, FeSO4 plus twice H2O. So this, if we are taking concentrated here with Fe, not with FeO or FeOH whole twice, because they are basic compound, so we need just dilute H2SO4. Concentrated is not used. But in case of Fe, we can take concentrated H2SO4, but the type of reaction will be changed. As you know that it is oxidizing agent. Which one? H2SO4, concentrated H2SO4 is oxidizing agent. So will oxidize Fe to Fe2 faster, that is in the form of FeSO4. Will reduced into SO2 and water will be formed. So here 2 and 2. Now similarly your that saturated solution of FeSO4 will be evaporated. To get green vitriol crystals, the FeSO4 is a saturated solution, right? Plus it will add 7 water molecule from saturated solution, and after evaporation it gives FeSO4 dot 7 H2O, that is green colored crystals will be formed. In this way, we are able to prepare almost all the salts. Just global salt is left. So, next topic we will do the analytical chemistry. Thank you.